Hello friends, welcome to Susan and John Matthew. In this video, we are going to continue with method of separation of variables for solving second order partial differential equation. Now, I hope you understood the separation method from the previous video. If not, make it very clear before watching this video. Anyway, in this video, my plan is to teach you three problems which has been repeated again and again in your past papers. I have collected 6 questions from your past paper. So in this we will learn 3 of them. Even though it's only 3 problem, it takes a long time to solve partial differential equation, and in examination you have to be perfect with this method so that you can solve it within time. Anyway, after this video, the method will be very clear. And second thing, you will understand how to play with the constants. And you will also understand when to use trigonometric solution and when to use trigonometric and exponential solution. And finally, the most important thing, that is applying boundary condition. Now look at this. Usually in examination they ask to solve wave equation, and they may ask you to derive the wave equation or the heat equation, solve the wave equation, solve the heat equation. For all those things, this method should be in very good condition. And they also ask problems based on separation, either the problems which we are going to do today or the problems which will be based on wave and heat equation. Anyway, get connected with us and let's start. So the first problem they asked very recently, and that is only for 2 mark. Now it's a long process, but can you see they have given a very nice problem here. Point number 1, they didn't give any boundary condition, and that's a wow, because as a student you can be very happy, because if they do not give you boundary condition, you can leave your answer in terms of C1, C2 or the arbitrary constant. You don't have to waste your time finding the values of the constant. Second thing, I can see that this equation has been differentiated only in terms of x. And that means this question is going to be super simple. Anyway, let's start. So let's write like 3 del square u by del x square plus 2 del u by del x, so that it looks like our standard equation. Now, what should we do? Come on, you learned it in the last video. Let it be any second order equation in the standard form. We assume the solution to be, look at this. This is our answer. This is our solution. So in every problem which you do with separation, the solution will be x into y. And x is a function in x and y is a function in y, which we are going to find. Now, solution will balance the equation. I showed you one example from trigonometry, from quadratic, from derivatives, etc., etc. in the last video. So the solution can be replaced with this u. So I'm going to do that. So I'm going to write 3 del square by del x square of x into y plus 2 del by del x of x into y is equal to 0. Now wait a minute. I know some of you are just watching this video without pen and paper. If you are one of them, pause the video, get some paper and pen and start scribbling these things with me. Then only the method will be perfect. It's a long method. If you watch, you might understand a little bit, but if you work out, it'll be perfect. Okay, let's convert it into the standard form. 3x double dash y. How did I get it? Oh, I'm differentiating partially with respect to x. Plus 2 multiplied by x dash into y equal to 0. Now, I'm going to take that y common. So, I get 3x double dash plus 2x dash is equal to 0. Now, think about it. If someone tells you a multiplied by b equal to 0, that means one of them must be equal to 0. Either A should be equal to 0 or B should be equal to 0. Okay, so that means I'm going to get y equal to 0 or 3x double dash plus 2x dash is equal to 0. But wait a minute, if y becomes 0, then we are going to get something really trivial. Trivial means something which is kind of like very silly. Come on, if y equal to 0, our solution will become 0. And it is obvious 0 will balance the equation. So we get the trivial solution. So this is an impossible case. So the only case we have to deal with is the x part. So I'm going to get 3d square x. I'm converting it in the standard notation that you learned in your first semester. Plus 2 into dx is equal to 0. 3d square plus 2d of x is equal to 0. Now the auxiliary equation. I hope you still remember. Do you remember your first semester? First of all, I write auxiliary equation. 3m square plus 2m equal to 0. Use a calculator and solve it. I got m equal to 0, m equal to minus 2 by 3. And I can see the roots are distinct. So my solution will be x is equal to c1 e to the power 0 x plus c2 e to the power minus 2 by 3 into x. That is x equal to c1 plus c2 e to the power minus 2 by 3 into x. We get u is equal to, if you want, you can write this directly. C1 plus C2 e power minus 2 by 3 into x as the final solution. I'll give you a logic for that. Earlier we got y equal to 0, right? So dy by dy will be 0 because if you differentiate 0, you'll get 0. That means the differential of y will be 0. So y is a constant. So if you multiply by that, because the solution is x multiplied by y, again this will go inside and create this as constant. So in problems like this, you can be sure that you deal only with x or only with y. Now let's go for the next problem and mark it super important. It's very, very, very important because they have started giving boundary conditions. So solve the second order partial derivative equation. So solve the second order partial differential equation given by this. Please copy the question and our usual drama. Let z equal to, why did I take z equal to? Because the function is named as z. Let z equal to x into y be the solution. Anyway, don't expect a trivial case like the first one. And I wrote the equation. Solution will balance the equation. So converted it into standard notation. Okay, now look at this. This means x double dash by x is equal to y double dash by y multiplied by 4 is equal to lambda. I hope you still remember the method we learned in the last video. Now equating the first and last, x double dash by x equal to lambda means equal to lambda times x and 4y double dash equal to lambda times y. So x double dash minus lambda x equal to 0. 4y double dash minus lambda y equal to 0. And you can convert it into the standard notation and you'll get this. It's the same thing that we had been doing for a long time. Okay, and then I'm going to solve this. So the auxiliary equation. And I got m square equal to lambda, m square equal to lambda by 4. And those who watched the first video will understand what to do now. Come on. In our first problem in the last video, we got stuck inside a square root. And of course, I am allergic to square root. Many people hate square root and I am one of them. So I want to escape. Now, think for a moment. I want you to remember this formula. Do you remember the formula? If the roots are distinct and real, this will be the solution. That means our solution will be pure exponential. If the roots are equal, again our solution will be pure exponential multiplied by linear. And if the roots are complex, our solution will be exponential multiplied by trigonometry. Now, in this question, in this particular question, this is something very important, note it down. In this question, by looking at the boundary value, can you see? By looking at the boundary value, can you see it's clearly given when y equal to 0, the function will be trigonometric. When y equal to 0, the derivative will be trigonometric. And by looking at that condition, I'm 100% sure I want a trigonometric answer. And for that purpose, I'm going to put lambda equal to minus a square. Once more, if I want an exponential function, I will keep plus a square. If I want sine and cos, I will keep minus a square. Now look what will happen here. And some people even go one more step ahead. They keep like 4a square to cancel this 4. You can keep any number, but make sure if you want sine and cos, you keep negative. So look at this. M equal to plus minus root under minus a square. And here m equal to plus minus root under minus a square divided by 4. So we get m equal to 0 plus minus I into a. And here m equal to 0 plus minus I a by 2. Once more, understand this step properly. We did the same thing till now. But like I told you in the first video, I got lambda inside the square root and immediately I want to escape the square root. Not compulsory, but still we do it. And I have two options. I can keep like plus a square or minus a square. But if I keep plus a square, I will end up getting exponential function, which I do not want because I already looked at the question. Look at the boundary condition. And for that reason, I kept minus a square so that I'll get the solution to be e power 0x c1 cos ax plus c2 sin ax. And here I'll get the solution y is equal to e power 0x c1 cos a by 2y. If you want to avoid fraction, you can keep a better constant plus c2 sin a by 2 into y. Okay, and e power 0x is 1. Anyway, I got the solution x equal to this one because that e power 0x, can you see? I got this e power 0x to be 1 and I got the remaining part. This is equal to 1. And what is the solution in separation of method? X multiplied by y. So I got the answer. Now look at this. You cannot stop here because in this problem, you can stop only when you get C1, C2, C3, C4. Why? Because in the question they gave the boundary condition. So look at this. We already got the answer, but we cannot leave it here. Anyway, I want you to read the question once more. I'll keep the question here so that you can read very easily. This is the question. But can you see they have given boundary condition, and to apply boundary condition, I'm going to differentiate. If you are confused, pause the video, think for a moment. Once more, we already got the answer, which cannot be written as the answer because we don't know C1, C2, C3, C4. Now in problem 1, as a student you had an advantage. They never ever gave the boundary condition and we don't have to find the constant. Okay, so I'm going to find the derivative and we are differentiating with respect to y partially. So the derivative will be, the derivative of cos is minus sine and this constant will come. So I'm going to write minus a by 2 c3 sine a by 2 into y plus a by 2 c4 cos a by 2 into y. Okay, now I multiplied this so that we can, can you see this and this are the same. I just multiplied it c1 c3 And now we are ready to apply the condition. Now look at this. These problems are always very, very long. So now and then read the question. So I have kept the question here. Now look at this. According to this, I can plug in z equal to sine x by putting y equal to 0. So that's exactly what I'm going to do. I'm going to take this solution and I'll put z equal to sine x according to what they gave, and I'll plug in y equal to 0. Now you know very well sine 0 will be 0. So this term will vanish and this term will also vanish, and I'm going to get, and what about the remaining part? So I'll get sin x is equal to c1 c3 cos ax, c1 c3 cos ax, and this will become 1. Once more, sine 0 is 0, so this is gone. Sine 0 is 0, this is gone, and cos 0 happens to be 1, so I'll get something like sin x equal to plus c2 c3 into sine ax. Now don't forget, our job is to find constant. So the left side can be written as 0 cos x plus 1 into sine x. I'm making it very clear. Is equal to c1 c3 cos ax plus c2 c3 sine ax. Don't forget our objective. We are trying to find the constants. So by comparing both sides, I got a lot of things. c1 c3 is going to be 0. C2 C3 is going to be 1, and obviously A is equal to 1. So we got a few things. Look at this. We need C1 C3, C1 C4, C2 C3, C2 C4. So I got two of them. Wait, we have one more condition. Can you see? According to the given condition, the partial derivative will become sin x when y equal to 0. And that is exactly why I found the partial derivative. So now look at this. In partial derivative, I am going to plug in y equal to 0. So this will vanish and this will become 1. So I am going to get sin x equal to c1 c4 divided by 2 cos ax plus c2 c4 divided by 2 sin ax. You think about it. Because what I did is I am plugging in y equal to 0 into the partial derivative, not here, not here, here. So this will become 0, this is gone, and this will become 1, and I'll be left with a by 2 c4, and I multiplied that a by 2 c4 inside the bracket. So I ended up like this, and if you want to understand, you have to scribble. Now this gives me 0 cos x plus 1 into sin x equal to c1 c4 by 2 cos ax plus c2 c4 by 2 sin ax. Again comparing, I get c1 c4 by 2 equal to 0, which gives me c1 c4 equal to 0. Look, I got 1, 2, 3. Again confirmed a equal to 1, and c2 c4 is equal to 2. That's it, we solved it. Now plug it into the first equation or the last equation. So we got the value of c1 c3. What is c1 c3? 0. And what is c1 c4? 0. c2 c4. So I'll plug all these things and I get the solution z equal to sin x cos y by 2 plus 2 sin x sin y by 2. Double check your answer. Okay, now let's go for the next question. Okay, now let's go for the last question. It's going to be even more lengthy, but now you will understand the technique. Now look at this. Solve the heat equation. When they claim heat equation, always remember it will be a combination of trigonometric and exponential. Imagine we take a cup of coffee, hot coffee or tea, and keep it here. After some time, the temperature will become the room temperature. The temperature of the cup will become the room temperature because heat will start to flow. And when, like what you call it, doesn't flow like a linear function. It flows slowly, slowly, slowly. So there will be a negative exponential power. If you look at the graph of e power minus x, it will come down, 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 and slow down. So it will be a combination of trigonometric and exponential. So you to understand that part very clearly. Anyway, the first part is 100% same. So look at this. The usual drama. So by the way, this is connected with time and the position of the plate. Usually we can imagine a plate or any place in the dimension. Okay, anyway, there's only one variable, so you can imagine a thin rod. Okay, so let u equal to x into t be the solution. The usual drama, look, solution will balance and converting it into notation, and you're getting that d square. Now look at this. What I told you is going to be true. Look at this. On one side, can you see when I take the inverse, what is the inverse of logarithm? It will become e to the power lambda t plus c. And if I simplify this, it will become e power lambda t into e power c. And this is another constant. If you want, you can call it like c3 or c itself into e power lambda t. You can call it anything. Yeah. And again, we are trapped with root lambda. Come on, you have two choices. You can put lambda equal to a square or minus a square to escape the square root. But I already know it's a heat equation. I got the exponential part here. I want the trigonometric part from the other equation. So I am intentionally putting minus a square. So I'm going to get m equal to plus minus root under minus a square, which gives me m equal to plus minus I into a, and which tells me m equal to 0 plus minus I into a, and which gives me the solution x is equal to what will happen. Once more, I put lambda equal to minus a square. So I got the solution e to the power 0x and c1 cos ax plus c2 sin ax. Once more, it's a heat equation. I know one part will be exponential and the other part will be trigonometric. And this is one, this will be gone. Okay, but wait a minute. Now I can write the solution is u equal to x into t. That is u equal to x is here, that is c1 cos ax plus c2 sin ax multiplied by, if you want you can call it c3, but I'm going to call it c. So c into e power lambda t, and you can multiply this. So u is equal to c1 into c cos ax plus c2 into c sin ax multiplied by e power. By the way, lambda is minus a square. We kept lambda as minus a square for our trigonometric solution. So I'm keeping the value of lambda. So we can make it even cute by putting this as a cos ax plus b sin ax multiplied by e power minus a square into t. That's it. We got the solution. But wait. I had to go back and check whether the solution is correct. No, my solution is not correct. Can you see they have given a lot of conditions here. They are given 1, 2, 3. So it is my job to find the values of the arbitrary constant. I have to find A, I have to find B, I have to find all the arbitrary constants. So let's start. So what I'm going to do is I'm going to put the conditions one by one. So can you read the first condition? The first condition is u0 comma t is equal to 0. Now you have to understand like this. The value of u will be 0 when I plug in x equal to 0 and t is equal to t. So let's plug it. So basically this is our final answer, which is still not the final answer because we don't know a, b and the small a. Okay, so I'm going to plug in the first condition. So 0 is equal to a cos, what should I plug in instead of x? 0 plus b sine 0 multiplied by e to the power minus a square into t, because t should be kept as t. Cos 0 is 1, sine 0 is 0. So I'm going to get a e power minus a square into t equal to 0. Now wait a minute. If someone tells you a multiplied by b equal to 0, one of them has to be 0. But do you know the exponential function can never ever become 0? Let it be e power minus something or let it be e power plus something. It can never ever be 0 unless it is shifted. Okay, so this is not possible. So a equal to 0. Good news. So we found one arbitrary constant. Did you get it? So we got a equal to 0. So I'll erase it. I'm going to write a equal to 0. I'm going to add that to the collection. Now I have second condition. Please read the question. The second condition is u l comma t is equal to 0. That means I have to plug in x equal to l, t equal to t, and the value of u will be 0. And the good news is now the solution has been reduced to b sine ax e to the power minus a square into t. So I'll plug it here. 0 is equal to b into sine al multiplied by e to the power minus a square into t. Now look at this. B cannot be 0. If b equal to 0, you'll end up with the trivial solution. And exponential cannot be 0. So the only possibility is this sine al will be equal to 0. And from trigonometry, you know that this means al will be equal to n into pi. Come on, a trigonometric function will vanish at every multiple of 5. Look at this, 0, pi, 2 pi, 3 pi, 4 pi. So at every multiple of pi. That means I got the value of small a, n pi by l. So we got the second thing. So I'm going to add to my collection. So I'll erase this. I got the value of a to be n pi by l. Now we have one more condition. Now look at this. You have to apply each and every condition. Okay, now the third condition is u x comma 0 is equal to u naught sine pi x by l. That means I have to keep the value of u to be this function and I have to keep x as x and t as 0. So let's do that. So I will keep u naught sine pi x by l is equal to the value of a we already know. So this whole term vanishes and b we have to find sine al because that's exactly the condition. B sine ax and e power 0. Can you see we have to keep x as x and t as 0 and e power 0 will be 1. Now comparing, I get b is equal to u naught. And if I compare this part, I will get a is equal to pi by l. Oh, okay. That means the value of n equal to 1. So we got the value of a. Now this is very important. This will be connected with the next video because if our answer comes in terms of n, we have to write something called sigma in our solution. Because it can be 1, 2, 3, etc. Our solution will come as sigma and we have to apply Fourier series to find the coefficients. Now this is so easy because we got n equal to 1. Anyway, the last solution is u is equal to, instead of a, plug in 0. So we get b. That is u naught and sine, what is the value of a? We got a as pi by l. Pi by l into x multiplied by e power minus pi square by l square into t. Once more, you might be slightly confused at what happened at the last. Watch the next video, you'll understand. Anyway, I'll be back with more videos like this. So till then, my friends, bye.